If not, link of the playlist is given in the description box below. You must visit previous lectures on circles, which not only elevates your JEE preparation but also gives you confidence to the problem solving skills. In today's video, we dive deep into the world of coordinate geometry on circles, covering family of circles, angle between circles, and the fascinating concept of orthogonal circles. Perfect for IIT aspirants, we will break down these topics with engaging examples and easy to follow explanations to help you ace your IIT Main and IIT Advanced exams. Whether you are preparing for your exams or just love math, this video is tailored for you. Don't forget to hit the like button and subscribe for more mind-boggling math insights. So first thing first, let us start our class today. So let us just give you a brief synopsis of the previous class. There we have covered the normal to circles. We know what is normal to circles. The normals are those lines which are perpendicular to the tangents at the point of contact. And for the circle, the normals are always passing through the center of that circle. If I draw any tangent at any point, let us say I have drawn a tangent to this point. So the normal is basically the line which is perpendicular to this tangent at the point of contact. This is the point of contact. So at this point of contact, if I draw a line which is perpendicular to the tangent, is what called your normal to that circle. And the normal to any circle always passes through the center of that circle. Okay. Next comes to chord of contact. If I draw a circle and from a point outside this circle, if we draw two tangents from a point outside the circle, if we draw two tangents, let us say the two tangents be this one and this one, and these two tangents are intersecting at a point outside the circle, and let us say this A and B. These are the 2 points A and B where the tangents are touching the circle. Now, if we join this AB by a line, then this chord is what called your chord of contact, right? And we know that the equation of the chord of contact, if this point, let us say x1 comma y1, then we know the equation of the chord of contact is t equals to 0. Where t has its usual meaning that we have already know. T is basically the equation, the expression for the tangents, like x1 plus y1 equals to a square. If the equation of the circle is x square plus y square equals to a square, right? So the equation of the chord of contact is t equals to 0. Then we are coming for chord bisected at a given point. Right? So if, let us take a circle here, and if there is a chord, this is, let us say, the chord, and this chord, if it is bisected at the point x1 comma y1, okay, this is the midpoint of the chord AB, then the equation of the chord is t equals to s1. Okay, what is S1? If the equation of the circle is x square plus y square minus s square, s equals to 0 is the given equation of the circle, then S1 is x1 square plus y1 square minus s square, right? So t equals to S1 is the equation of the chord bisected at the point x1, y1. And what is the combined equation of this pair of lines? It will be S1 equals to t squared. That is the combined equation of pair of tangents. Clear or not? Okay, then we have learned intersection of the circles and common tangents. So we have discussed about the 5 such cases which can occur when two circles are not intersecting each other. In that case, what was the condition? The condition was if this is C1 and this is C2 and the radius of the circles are R1 and R2. So when C1, C2 is greater than R1 plus R2, then we will say that these two circles are neither intersecting nor they are touching each other. In that case, we are going to have 4 common tangents, out of which 2 will be your direct common tangents and 2 will be transverse common tangents, right? This we have all already covered in our previous class. And then if say these two circles are touching each other, if these two circles are touching each other externally, then the condition was C1, C2 equals to R1 plus R2, where R1 and R2 are the radii of the given two circles respectively. And in that case, we are going to have 3 common tangents, out of which 2 will be DCT, that is direct common tangent, and 1 will be transverse common tangent, right? Now, when the two circles are intersecting each other, in that case, your condition was, if this is C1 and this is C2, the condition was C1, C2 is greater than modulus of R1 minus R2 less than R1 plus R2, right? In that case, we are only having 2 common tangents and both of those tangents will be direct common tangent, right? Now, if there are 2 circles which are touching each other internally, in that case, the condition was C1, C2 equals to modulus of R1 minus R2. In that case, we are only having one common tangent, which is your the direct common tangent. There will be only one common tangent, and that is a direct common tangent, right? And the last but not the least that we have done is that when one circle is in the other circle, in that case, the condition was your C1, C2 is less than modulus of R1 minus R2. And in that case, there will be no common tangents. Is it clear? So these are the intersection of the circles and the common tangents. These are the 5 cases that we have discussed. Next was length of direct common tangent. We know that the length of direct common tangent, it was L equals to root over of d square minus R1 minus R2 whole square. This is the length of direct common tangent, dct. Okay, what is d? D is the distance between the center of those two circles, and R1, R2 are the radii of the respective circles. And for transverse common tangent, the length L was root over d square minus R1 plus R2 whole square. This is for the transverse common tangent, right? Again, in this case also, your d is the distance between the two centers of the circle, and R1, R2, as usual, they are the radii of the given two circles. Okay. Then we have learned about how to find out the equation of DCT and TCT. For direct common tangent, we have learned that the line joining the two centers of the circles will intersect the direct common tangent at a point which divides the line joining the two centers in the ratio R1 is to R2 externally. And for transverse common tangent, the transverse common tangent will intersect the line joining the two centers of the circles in the ratio R1 is to R2 internally. And then we know how to find out the equation of DCT and TCT. Again, I am telling you, all of this I have already discussed in lecture 3. So you are all advised to see that class immediately if you have not seen that class. Okay, because you can only go along with me through this class, only you have the preconception of whatever we have done in lecture 3. So that is why I told you in the beginning of the class that the link has been given in the description box. You please go and check that video first, and then you come for this lecture for better understanding of this class. Okay? So now let's move further. Today's topic is what called your family of circles. See, it's same thing as your in the case of straight lines. What we have learned, suppose we have given you two straight lines. Suppose we have given you two lines, L1 equals to 0 and L2 equals to 0. Now, these are the two intersecting lines. Now, if I ask you, find out the equation or find out the family of lines which are passing through this point of intersection of these two lines, the intersection of these two lines, then what you have done, you have simply written lambda 1 plus L1 plus lambda L2 equals to 0. So this is the equation, the family of lines which are passing through the point of intersection of L1 and L2. Same thing here. Suppose we have been given one equation of a circle which is x square plus y square plus 2gx1 plus 2fy1 plus c1 equals to 0, and the line is given L equals to 0, which is ax plus by plus c equals to 0. So there is one circle, and there is one straight line. Now these two are intersecting at 2 points. Okay, like this. Now you tell me how many number of circles are possible through these 2 point of intersection. Obviously, infinite number of circles are possible. So these are all family of circles which are passing through the point of intersection of this given circle and this line. So equation of all those family of circles is represented by S1 plus lambda L equals to 0. As same in the straight line. When we are saying that two straight lines are intersecting at a point, so find out the family of lines which are passing to the point of intersection of this point, then it will be write down one equation plus lambda times the other equation equals to 0. Same thing here. There is a circle, there is a straight line, they are intersecting at 2 points. So all the circles which are passing through the point of intersection of this line and the circle will be simply S1 plus lambda L equals to 0. That's it. Is it clear? So this is our case 1 of family of circles. When you are finding out the family of circles passing to the point of intersection of a given circle and the line. Right? Okay. Now there are two circles given to us. Let us say one is S1 equals to 0 and another one is S2 equals to 0. So let me just draw two circles. These are the two circles. One is S1 equals to 0 and another one is S2 equals to 0. Okay. Now these two circles are intersecting each other at 2 points. This is one point A and this is the second point B. Okay. Now all the circles which are passing through these 2 points are the family of circles of this given two circles. Are you getting my point? All the circles which are passing to the point of intersection of these two circles are the family of circles whose equation is given by S1 plus lambda S2 equals to 0. Is it clear? All the circles which are passing through A and B is given by S1 plus lambda S2 equals to 0. But remember one thing, here your lambda will take any real value except -1. Because you can see if your lambda becomes -1, then your S1 minus S2 equals to 0. It no more remains a circle because your x square, y square, x square, y square will get cancelled. So it no more remains a circle, it will become a line. It will be an equation of the line. This line is what called your radical axis. That we will learn in the next lecture. So I'm not talking about radical axis right here. But only remember, if your lambda becomes -1, this will become the equation of a line, not the equation of a circle. So we should be very careful about when we are finding out the family of circles passing to the point of intersection of two given circles. In that case, your lambda should not be taking any value like -1. It can take any real value, doesn't matter, but it should not take -1. Have you understood the logic behind it? Okay, now let us come for the next family of circles, which are called concentric circles. You see, suppose a circle is given to us, which is your S1 equals to 0. Now we all know that for this circle, there will be infinite concentric circles, isn't it so? There will be infinite concentric circles. This circle, it can be this circle. What do you mean by concentric circle? Whose centers are same? Only the radius will differ. This I have already discussed in the previous lectures, but still I am telling you here, since we are covering family of circles, so it comes into the family of circles itself. So in this case, for S1 equals to 0, the equation for all the concentric circles will be nothing but it's the same equation, you see. Only thing is that I have changed the constant term. Here it was C1 and I have replaced C1 by lambda. So this equation is going to represent the family of circles which are concentric to the circle S1 equals to 0. Right? So till now, what we have learned about the family of circles, we have learned three cases. One is when there is a point of intersection between a circle and a line. Then the equation of the family of circles is what? S plus lambda L equals to 0. When there are two circles intersecting each other, then what we got? S1 plus lambda S2 equals to 0. Lambda can take any value except -1. We have already discussed. Here we have already discussed this one. Okay. And the third one we have learned that when how to find out the family of circles which are concentric to a given circle. These three things we have learned. And remember, students, one thing I am telling you. One thing I am telling you, please, if possible, make a note of this. That whenever you are getting a point of intersection between a circle, remember three things only. Number one, when you are getting the point of intersection of a circle and a line, you are going to find out its equation, I mean the family of equations, simply by writing this thing. This is one way of finding out the family of lines. When you know a circle and when you know a line and they are intersecting at two distinct points, A and B, so any circle, any family of circles passing through these 2 points of intersection, we can find out by S plus lambda L. Number two, when two circles are given, what we do, we simply write the equation of those two circles and I add a parameter lambda over there, which is equals to 0. So this represents what? This represents all the family of circles which are passing through the point of intersection of two circles, S1 equals to 0 and S2 equals to 0. So mainly we have to remember these two things. For finding out the family of circles, you have to remember these two things. And the third one we got, when it is a when they are concentric circles, then what we do, we write the same equation and simply we change the constant in the equation of the circle. That's it. That's how we find out the family of concentric circles, right? Now, whatever cases I am going to consider after this will be derived from this, mainly from this method 1. Okay, mainly from this method 1, we will try to find out the equation of the family of circles. Let us consider case 4. See in this case. In this case, what they have said, they have simply said that a circle is there and they have said that this circle is passing through two given points. That's it. It is saying that this circle is passing through these two given points. You have to find out the family of all circles which are passing through these two given points. This circle which I have drawn is one of those circles. So find out all the family of circles which are passing through these two given points. That's it. Nothing else is given to you. So what to do in this case? Because we know, as I told you, I have to remember only one thing, that I have to find out the point of intersection between a circle and a line. If I know the point of intersection of a circle and a line, we can find out the family of circles right from there by simply doing S plus lambda L equals to 0. Am I correct? That's exactly what I'm going to do here. So what I will do, I will try to find out first the equation of that circle. Let me just remove this circle because this circle is actually not given to us, right? This circle is not given to us. We have to simply find out all the circles which are passing through these 2 points. So first what I will do, let us say this point B, x1 comma y1, and this point B x2 comma y2. Now what I will do, I will try to find out a circle and a line. So for that, to find out the equation of the circle, what I'm doing, I'm simply joining this line. And I try to find out the equation of that circle whose extremities of the diameter are x1, y1 and x2, y2. That's it. So the equation of the circle whose extremities of the diameter are x1, y1 and x2, y2 is given by x minus x1, x minus x2. This we all know. Y minus y1 into y minus y2 equals to 0. So this is the equation of the circle in which AB is the diameter. Is it clear? So now let me just draw the circle now, which is actually this one. Is it clear? Now this is the equation of that circle whose AB is the diameter. Now what I try to do, because now I need to find out the family, I need the equation of the line. And the equation of the line, we can write this thing as, we can find out the equation of the line AB by using 2-point form. And the 2-point form was y minus y1. What was the 2-point form? Y minus y1 by y2 minus y1 equals to x minus x1 over x2 minus x1. Right? This is same as writing in the determinant way, writing the equation of the straight line passing through 2 given points, x1, y1 and x2, y2 in the determinant form in this way. Okay, so this is the equation of the straight line AB. Now you observe, you got this circle, you have this line. Now my main question, actual question is that find out all the equation of the circles which are passing through these 2 points. Is it not the same of finding out all the circles which are passing through the point of intersection of this circle and this line? Hello? Yes or no? Absolutely. Therefore, the equation of the family of circles passing through the point of intersection of this circle and this line is given by this one. Am I correct or not? Am I correct or not? Yes or no, please tell me. Absolutely correct. Okay, so what I did, whatever condition is given to us, I am only thinking about 2 things. One is, give me the equation of the circle and give me the equation of a line, and they are intersecting at 2 points. I will find out the family of all the circles passing through this point of intersection of this line and this circle. That's it. So that's exactly what was my motto. In the question, in our question, in this case, only 2 points are given. Nothing else is given to us. Neither the equation of the circle nor the equation of a line is given to us. So what we have done, we have forcefully found the equation of the circle and the equation of a line, which are intersecting at these 2 points, which is given in the question. So after doing that, I have simply applied the funda S plus lambda L equals to 0. That's it. Is it clear? Absolutely. Okay, let's move for the next case. This is more interesting. You see, here I have only said that find out all the family of circles which are touching this line. Touching this line
and at the point, say at this point. This point is what? This is my x1 comma y1. That's it. Nothing else is given to you. Now you have to find out the family of circles. You see, there will be family of circles here, where this line will be a tangent to that circle and tangent at x1, y1. Isn't it so? Circle can be like this also. Lot of circles can be drawn. This infinite number of circles can be drawn. Right? So now we have to find out the equation of all such circles. How to do this? Again, we want two things. See, this circle is not given to us. Only this line is given and this point is given, nothing else. So from here, if you want to find out the family of circles which are touching this line at the point x1, y1, I need two things. Again, the same basic. I need two things. What are those? One, give me a circle. Two, give me a line. And we have been given this line which is L equals to 0. But I don't have any circle. So how to find out circle? Simply by having one point. Hello? How can we find out the equation of a circle having only one point? You see, a point is also a circle. A point is also a circle whose radius is 0. It is called point circle. So we are having a circle whose center will be x1, y1, but radius is 0. So what will be the equation of that circle? It will be x minus x1 whole square plus y minus y1 whole square equals to 0. This is the equation of that circle. Which circle? The point circle, whose center is at x1, y1. That's it. So now we have a circle and we have a line. So in the question, they have asked us to find out the family of circles which are passing through x1, y1 and touching this line. This means what? It is actually we are finding out all the family of circles which are passing to the point of intersection of this circle and this line. So what will be its equation? The equation of the family of circles will be x minus x1 whole square plus y minus y1 whole square plus lambda L equals to 0. Tell me yes or no. Yes or no? So these are the 5 cases that we have to remember. Now, interestingly, actually we have learned 3 cases. One is when we have been given a line. You see, let me just go for that slide. See this slide? Here we have learned that when a circle and a line is given, how to find out the family of circles. This is the main conception of finding out the family of circles. Okay, and after that, in case 2, we have learned when 2 circles are given and we have to find out all the circles, all the family of circles passing to the point of intersection of these 2 given circles. So in that case, what we have done? We have simply written the family of circles is S1 plus lambda times S2 equals to 0. And one thing we should be careful at this case, in this case, is that your lambda should not take any value like -1. Other than that, lambda can take any value. There is no problem. Why? Because I told you that when lambda becomes -1, it will become a line, not a circle. Okay. The third one we have seen, it is the concentric circles. This we have already learned. Here nothing new has been created. Only thing is that in place of that constant C1, whatever is given in the equation of the circle, we will replace that constant by some other parameter. Okay, in this case I have added lambda. Clear? Now from the fourth and in the fifth one, in fourth and in fifth, there is no such conditions. I mean, a circle and line is given to us. So what we have done, we have forcefully created a circle and a line. Every time you should remember that. You have to create a circle and you have to create a line. The moment you have a circle, let us say S equals to 0, and the line, let us say L equals to 0, we will simply write the equation of the family of circles as S plus lambda L equals to 0. That's exactly what I have done here. When only 2 points are given to us, they have said find out the family of circles passing through these 2 given points. So what I have done, first I have created a circle passing through these 2 points. How? We have formed a equation of a circle where this A and B, these 2 points are the extremities of a diameter of a circle. So that diametric form we got. And then we found what is the equation of the line AB, right? So family of circles passing through these 2 given points is same as family of circles passing through the point of intersection of this circle and this line. So that's exactly what I have written over here. And a new thing that we have learned for class 11 students, for class 12 students, they all know. But for 11 students, we must know that when we have 2 points, we can find out the equation of the line by using this 2-point form. This is exactly the same thing when we write it in a determinant form. Okay? So this was our case 4. And then in case 5, they have said the line is given and a point is given. So you have to find out all such circles which are passing through this point x1, y1 and the line L is tangent to this circle at this point. So again, we have formed the equation of a circle. In this case, the circle is a point circle and line we know. So what we have done, we have simply done the same thing, S plus lambda L equals to 0. That's it. Okay, the line L is given to us in this case. Okay, so now let's move for problems based on family of circles. So in this question they have asked, find the equation of the circle through the point of intersection of these 2 given circles and touching the line x plus 2y equals to 0. What do you mean by that? You have to find out the equation of that circle which is passing through the point of intersection of these 2 given circles and touching the line x plus 2y equals to 0. It means what? X plus 2y equals to 0 will be a tangent to that required circle. So any circle which is passing through the point of intersection of these 2 given circles will be written as lambda times x square plus y square minus 1 equals to 0. Now one question frequently comes that, sir, which circle we have to take first and which circle we have to take the second one. The answer is you can take any of these 2 given circles as the first one and the other one as the second one. There is no harm. Okay, I have taken this thing as my first one and this thing as my second one. You can simply do its reverse. It doesn't matter, you are going to have the same answer. So don't worry about it. So therefore, the equation, whenever you write the family of circles in this way, you always, first of all, you write in this way and then you simplify it to its general form. First you write down that family of circles and then you convert that in the general form. So it will give you something like this. Let me just simplify a little bit. Is it clear? Therefore, now this is the family of lines in the general form. Okay, so what is its center? The center of this circle will be right, and what will be its radius? Root over whole square minus, am I correct? This is the radius. So let me just simplify this first. Sorry, it will be 4. 4 plus lambda square divided by 1 plus lambda whole square. Am I correct or not? So this is your radius, right? And the center is this. And as x plus 2y equals to 0 is a tangent to this circle, so again that old conception we will use, that from the center I will drop a perpendicular on the tangent and it will be its radius. That's it. That's the conception we are using every time, and throughout circle we will use that conception only, as I told you in the previous classes also. So what will be the perpendicular distance drawn from the center? So this is the perpendicular distance drawn from the center on the tangent, which is nothing but your radius, and which is, am I correct? So let me simplify a little bit. So if we square both sides, we are getting this goes off. So we are left with, so lambda square is coming to 1, implies lambda is coming to plus minus 1. Okay. Now we have to be little careful about at this point is that your lambda cannot take the value minus 1, right? Because if lambda is minus 1, as I've explained, that it will no more remain a circle, it will become a straight line. That straight line is what called your radical axis. I've already told you. So lambda equals to minus 1, I have to reject it. So we have to take lambda equals to 1. Is it clear? Then what will be its equation? Let me put it here. 2 over 1 plus 1, that is 2. 4 by 2. And this part comes to 0, which is equals to 0. So the final answer will be x square plus y square minus x minus 2y equals to 0. Is it clear to all of you? You see, in this question, what new things we have done here? Nothing. Simply, we have used the new conception, how to find out the family of circles. We got that. And then we are always using the conception that we have already discussed, that whenever we are having a tangent, we are always dropping a perpendicular from the center on the tangent and equating it to its radius. That's exactly what we have done to find out the value of lambda, right? And after getting the value of lambda, simply put it in that family of circles, and there you are going to get that particular circle over there. Is it clear? That's exactly what we have done. So let me reveal the answer now. Yeah. So x square plus y square minus x minus 2y equals to 0 is that required equation of the circle. Okay, let's move for the next problem. So in this question, they have given that the find equation of that circle passing through the point of intersection of these two given circles. So we have been given two circles and we have to find out the equation of that circle which is passing through the point of intersection of these two circles. Okay, so what we have learned? We have learned that when the two circles equation are S1 equals to 0 and S2 equals to 0, so the family of circles passing through the point of intersection of these two given circles is S1 plus lambda S2 equals to 0, right? And to find out the value of lambda, they have given us the condition that its radius will be equals to 4. Okay? Therefore, the family of circles, let me just write it here first. The family of circles which are passing through the point of intersection of these two given circles is given by this. So after getting this, Let me just convert this in the general equation. So we are getting thus the general equation of the circle becomes is it clear? Therefore, its center is at thus its radius will be am I correct? So this is its radius. Now, according to the problem, this is equals to 4. So simply by solving this equation, we are going to have the value of lambda. So let me just try to solve it. Let me square both sides. Square both sides. So let me open the brackets. So what we are getting? This is 25 lambda square, 36 lambda square. So that gives us 61 lambda square minus 40 lambda square. So that gives us 21 lambda square and minus 16 lambda square. So it is coming to 5 lambda square. 10 lambda plus 24 lambda, that gives us 34 lambda. From here we are getting 9 lambda. So minus 36 lambda. That is minus 2 lambda. So minus 34 lambda. Then we are having 1 plus 4, that is 5, plus 4, that is 9. 9 minus 16 gives us minus 7, which is equals to 0. Am I correct? So if I now factorize this, what we are going to have? Thus, we are getting two values of lambda from here. One is 7, another one is minus 1 over 5. Is it clear? So we got two values of lambda. One is 7, another one is minus 1 over 5. So let me now put the value lambda equals to 7 in this equation to get the equation of the circle. So if I put lambda is 7, what we are going to have? Right? So let me just simplify a little bit. So if we cancel this, we are going to have, therefore the equation comes to this is my one equation of the circle, and another equation of the circle we will get when we put lambda equals to minus 1 over 5. So let me just put it here. In equation 1, we are getting this one will become 0 minus 2 times. So we are having getting Is it clear? So let me reveal the answer. Yes. So have you understood this problem? Same type of problem. We have been given two circles and they have said that the required circle is passing through the point of intersection of these two given circles, and its radius is 4. So I have used the family of circles equation, and then we found the center and radius and equated to 4 to get the value of lambda. And after getting the value of lambda, we simply put it in equation 1 to get its equation. That's it. That's exactly what I've done here. It's so simple, right? Okay, let's move for the next problem. The question is, given the circle, there are again one circle and one line is given. And they are saying that this circle and this line are intersecting at two distinct points AB. You have to find out the equation of the circle with AB as diameter. So let me just draw the circle first. And let us say our line is this one. This is the line, okay? So the equation of this circle is x square plus y square equals to a square, and the equation of this line is x cos alpha plus y sin alpha equals to p. Now you have to find out the equation of that circle which is passing through this point of intersection, taking this AB as a diameter. What is A and what is B? These are the point of intersection of this line with the given circle. This is A and this point is B. So you have to find out the equation of this circle. The red circle, you have to find out its equation where AB is the diameter of that circle. So what I will do? I will write any circle which is passing through the point of intersection of the given circle and the line, that is through the point A and B, is given by Now let me write it in a general form. Therefore, its center is at okay. So this is the center of my required circle. Okay, because actually this is the center of that family of circles, but in our required circle which we want, is basically the center of that circle. Now, center, as AB is the diameter, therefore its center, that is this one, must lie on the given line. Yes or no? As it is the diameter. So the center is definitely on the diameter. Okay? Therefore, it must satisfy this equation. Therefore, we are getting. So if I take minus lambda over 2 common, so it is coming to 1 because sine square alpha plus cos square alpha is 1. So from here we are getting alpha is basically minus 2 times p. Right? Therefore, the required equation is. Therefore, the equation will be. Is it clear to all of you? Is this problem clear to all of you? Okay. So I have done by this method by using the family of lines. Now I'm telling all of you, those who are seeing this video, I will tell you that you please suggest me another method of doing this sum. Simply give me the idea. I don't need any calculation because answer definitely it will come this. What I will suggest to you, you please write down in the comment box what should be the other approach to solve this sum. Okay, I will definitely get back to you telling you whether your idea is correct or not. Okay, so now let's move for the next problem. The question is find the equation of the circle passing through these two given points and having its center on this line. Okay, almost same type of question. So what I will do, I will simply use, first I will use, this is method 1. First I will use the conception of family of lines. So what I will do, I will find out the equation of the circle where these 2 points will be the extremities of the diameter. So the equation will be, this is the equation of that circle in which your point A is this point and B is this point. These are the extremities of the diameter. Now, what is the equation of the line passing through these two given points? I want to find out the equation of line AB. What is equation of AB? This is nothing but in the determinant form I'm writing. Now, let me expand this determinant. So, this is the equation of the line. Now, any circle which is passing through these two given points is same as the circle which is passing through the point of intersection of this circle and this line. So the family of circle will be, is it clear? So let me just write it in the general form. Correct? So what is its center? The center of this circle is, okay, as they have said that the center is lying on this line. Hence it must satisfy this equation. So we are having getting lambda as equals to 2, right? Therefore, the equation will be, I am putting the value of lambda in this equation to get its equation. So this is the required equation of the circle. Is it clear to all? Now I will again suggest you, please tell me the second method of solving this sum in the comment box. I will definitely get back to you to tell you whether your idea is right or wrong. Give me the suggestion, write it in the comment box so that other people can also see your idea. Okay? Then I will definitely comment on that, whether your idea is correct or not. Okay, let's move for the next problem. The question is, find the equation of the circle passing through this point and touching this line at this point. Okay, that is, at this point, the given line is a tangent. So you have to find out that equation of the circle which is passing through the point. Let me draw the circle first. Let us say this is the circle, and they have said that this line is a tangent to this circle at the point. Okay. Now we have to find out this circle which is passing through another point given q equals to 1, 2. And the equation of this tangent is 2x minus y equals to 5. So again, I will solve this problem with the help of family of lines, because other methods more or less you know, because if you have gone through all of my lectures, you know more or less how to find out the equation of this circle by using some other method other than this family of lines. So I'm always trying to concentrate, particularly on this lecture, I will concentrate on family of lines because we have learned this thing in this lecture, right? So in this case, any circle which is passing through the point 2 comma minus 1 and 2x minus y minus 5 equals to 0 is a tangent is given by I have considered the point circle plus lambda times. Okay. Now this is the family of lines which is passing to the point P, and 2x minus y equals to 5 is a tangent to that circle. Now in our question, it is passing to the point 1, 2. Hence it must satisfy this equation. So from here we are getting lambda equals to 2 again. So therefore the equation is let me just simplify a little bit. So the equation is coming to is it clear? So this is the required equation of the circle. Okay, so let's move for the next problem again. This sum came in JEE Main 2019. What they're saying? A circle touching the x-axis at 3, 0 and making an intercept of length 8 on the y-axis passes through the point. 4 points are given. We have to find out that the required circle is passing through which point among these 4. That's the question. Again, I'm telling you, we know how to solve this question by other method because we have already done those methods before. But what I will try to do, I will focus on family of lines because this is a new method that you are learning in this lecture. So I will solely concentrate on family of lines and I will try to solve this problem by using family of lines conception. Is it clear? The other method, I will suggest all of you to please try. Until and unless you try, you will never learn. Never ever learn. Okay, family of lines is a new mode of solving a problem. So this is a new technique that we have learned today. So in the examination hall, I don't know which idea at that instant will come. So whatever idea it comes, you can solve it through that. Maybe it is your family of lines is one of them. It can also come. And family of lines, that much I can tell you, this is a method, you know, the students when they don't do anything, but if they do family of lines, family of circles, they can solve this kind of problem at ease. Right? So let me just concentrate this problem, solving this problem by family of circles itself. Okay, a circle is touching the x-axis at, let me just draw the diagram first. Let us say this point be 3, 0 and this length is 8 units. Clear? So, I will use the conception of family of lines. So, any circle which is touching the point 3, 0 and the x-axis which is y equals to 0 is a tangent. The equation is written as am I correct? Let me write it in a standard form. So what is its center? Right? So this is the center. The center is at 3, minus lambda over 2. Right? So what is its radius? Modulus of lambda over 2. Am I correct? As it is touching the x-axis, therefore the radius of this circle will be, as the center is 3, minus lambda by 2, therefore its radius will be lambda over 2. Now, let me drop a perpendicular from the center on this chord and let me join this. So this length is same as your this length, which is nothing but 3. At the same time, the length of the chord is 8. So this length will be nothing but 4. Therefore, its radius comes to what? From the Pythagoras theorem, the radius will come like root over of 3 square plus 4 square. That gives us 5. Therefore, we will say that modulus of lambda over 2, because this is nothing but your radius. So mod of lambda by 2 is nothing but 5. So that implies your lambda is coming to plus minus 10. Am I correct? Your lambda is coming to plus minus 10. Therefore, the equation of such circles will be x square plus y square minus 6x plus minus 10y plus 9 equals to 0. Because you can easily see that there will be two such circles possible. One is here and another one is here. That is why we are getting equation of two circles. The same will be here also, isn't it so? It is touching the point minus 3, 0 and it is intersecting the y-axis. It is cutting the y-axis of length 8. Okay, like this. That is why we are getting two circles. Now we have to check which point is going to satisfy either of this circle. So if I put 3, 10, we are getting 9, 100, 18 plus minus 100 plus 9. Okay. So we can easily see that if we take lambda equals to minus 10, from here we are actually getting, you see, 9, 9, and this goes off. So it is 100 plus minus 100, right? So when this is 100 minus 100, it is going to satisfy. That is, this point is very much on the required circle, because this point is going to satisfy the equation of the circle. This one, okay? The other circle is this one. So since this is single option correct, so I'm not going to check any other points, because it may so happen that if this question would have been a multiple, more than one option correct, then I would have checked all these points with the other circle also. Because in that case, there is a possibility that other points is going to satisfy the second equation. So that point will be also your answer. But in this case, since it's a J main question, so one option correct is there. Since I'm not going to check any more options, hence option A is correct. Is it clear to all? Absolutely. Okay, so let's move for the next problem. So in this question, they have said that two circles, each of radius 5 units. Let me draw two circles first. These are the two circles which are having the same radius 5 units and touching each other at 1, 2 and touching each other at 1, 2. Let us say, so these two circles are touching each other at this point, and this point is nothing but 1, 2. And if they have given that 4x plus 3y equals to 10 is a common tangent, we can easily see that this point 1, 2 is satisfying the given equation. Therefore, the common tangent is not the direct common tangent. They are actually talking about the transverse common tangent, which is passing through the point 1, 2, right? This is my common tangent. Now, the question is, we have to find out the equation of these two circles, right? Now, how to do this sum? The radius for each of these two circles is 5 and it is passing through the point 1, 2, 4x plus 3y. This equation is 4x plus 3y equals to 10, which is a transverse common tangent to these two given circles. Now we have to find out the equation of the circles. That's it. Now again, here we are going to, I will do it in two methods. Method one is, I will use the family of circles. So what I will say, the equation of any circle which is passing through the point 1, 2 and the line, this is the tangent to that circle, is given by am I correct in this case? Okay, so this will be the equation of any circle which is passing through the point 1, 2 and the line 4x plus 3y minus 10 is a tangent to that circle, right? Now let me write this equation in the general form. We are getting this is actually minus again. So 4 minus 3 lambda y plus 5 minus 10 lambda equals to 0, right? So what is its center? The center is at this is the center, and what will be the radius? Okay, and now by the problem they have said that the radius of the circle is equals to 5. Therefore, this will be equals to 5. So let me solve this equation to get the values of lambda. So if I multiply with 4, so now if we simplify, we are going to have this one will give us 25 lambda square. This is minus 40 lambda. This is 40 lambda. So this goes off. Again, this also goes off. So this is equals to 100. So from here we are getting lambda square is 4 implies lambda is plus minus 2. Okay, so we are going to have two such circles, and the circles are, let me put the values of lambda in this equation 1. So we get, if I put lambda is 2, we are getting minus 15 equals to 0. This is one equation, and another equation is, if I put lambda is minus 2, we are getting in equation 1. So these are the two equations of the required circles. Is it clear? So this is now my method 1, the way I have solved this sum by using family of circles. Now I will try to do it not by using family of lines. So this is my method 2. Let us say that the center of this circle be alpha comma beta. You see, we know the radius of the given circle, so we only need the center of the circle to find out their equation. That's it. So we know its radius, the radius is 5. Okay, and this line, the line joining the point of contact with the center of the circle, is basically perpendicular on the tangent. The slope of the tangent is minus 4 over 3. Am I correct? It's minus 4 over 3. Therefore, the slope of this line will be 3 over 4 because they are perpendicular to each other. So slope of, let me give a name of this line. Let us say this is AB. Okay. So the slope of AB is basically 3 over 4. Now what I'm doing, I'm using the parametric form to get the value of alpha and beta. At the same time, we will get the center of the other circle if it is alpha dash and beta dash by using the parametric form. What was the parametric form? Your alpha and beta will be the points, which is x1 plus minus r cos theta and y1 plus minus r sine theta, correct? Here the radius r is 5 given, and we have been given tan theta is 3 by 4. So if I draw a right angle triangle, this is 3, this is 4, so obviously this will be 5. So my sine theta will be 3 over 5 and cos theta will be 4 over 5, correct? Therefore the points will be 1 plus minus 5 into 4 over 5 and 2 plus minus 5 into sine theta, which is 3 over 5. Thus the centers are coming to 1 plus minus 4, 2 plus minus 3. So the centers will be, one is 5 comma 5 and another one is minus 3 comma minus 1. That's it. Therefore the equation of these two circles will be, we know the center. Let me take the center as 5 comma 5. In both the cases the radius is 5. So one center is 5 comma 5. So in that case the equation of the circle will be, which is 25. If I expand this, we are going to have plus 25 equals to 25. So that goes off. So we are left with the equation x square plus y square minus 10x minus 10y plus 25 equals to 0. Is it clear? You see exactly the same equation we got here. This is my one equation, right? And the other equation will be, if we take the center minus 3 comma minus 1, we are getting so let me expand this. Three square, that is 9 plus 1 is 10 minus 25, that is 0. So we are getting x square plus y square plus 6x plus 2y minus 15 equals to 0. See, the same equation we also got from the first method. Am I correct? Therefore, the two equations of the two given circle, the two required circles are, one is x square plus y square plus 6x plus 2y minus 15 is 0, and the other one is x square plus y square minus 10x minus 10y plus 25 equals to 0. So here I have done this sum by two methods. Okay. Now, if you ask me honestly, sir, which method you do like in this sum, I will say I will like the second method. And that's the magic. That's the magic of using parametric form in a straight line. By using the parametric form here, we got the center directly. Getting my point? That is why I told you while doing straight lines that you should be very, very comfortable with the parametric form of the straight lines. It is highly required and it will make the problem much easier and you can complete it in a very less amount of time. Okay? So now let's move for the next problem. Here the question says that a circle is given. Okay, in this circle, have you observed this? This circle is basically a family of circles, but the parameter is k. So let me write it. From here we are getting kx plus y plus ky. I'm just opening the brackets. So we are having the equation of the circle as x square plus y square plus y minus 1 plus k times x plus y minus 1 equals to 0, right? So actually this is a family of circles passing through the point of intersection of this circle and the straight line, this one. Is it clear? Now let us see what is the question. The question is, find the coordinate of these points. Which point they are talking about? This is intersecting at two fixed points. Okay. So we will simply solve these two equations, that is the equation of the circle and the equation of the line, to get that two fixed points. Which two fixed points? The points where the circle is intersecting the straight line x plus y equals to 1. So how to get that coordinate? To know the coordinate, you have to solve these two equations, right? So that's exactly what I'm trying to do here. We can write y is 1 minus x, and let me replace the value of y in the first equation. I mean in the equation of the circle. So if we open it, what we are going to have? Two x square minus 3x plus 1 equals to 0. So if we factorize, so we are going to have 2x minus 1 into x minus 1 is 0. So from here we can write that your x is half and 1. So the abscissa of that two fixed points are half and 1. So the corresponding value of y will give us half and 0. Is it clear? Therefore, the two fixed points are half comma half and 1 comma 0. Right? So the first part of this question is over. Okay, now you see a very interesting thing. In the second case, they have asked you, find the minimum value of the radius of a circle C. Find out the minimum value of the radius of circle C. Let me draw this thing first. This is my circle, and let us say this is the line. Okay? Now, this point is point A, which is actually your half comma half, and this point is your B. Let us say this point is 1 comma 0. Now, through these two points, there are infinite number of circles are passing. Now I have to find out the radius of that circle passing through these two given points, whose radius is minimum. Whose radius is minimum. Can you please guess what kind of circle they are talking about? Which circle they are talking about? Exactly. You have guessed it right. It is that circle whose diameter is the point, the extremities of the diameter are A and B. Are you getting the point? Where these A and B are the extremities of the diameter, in that case, this circle will have the minimum radius. This circle will be having minimum radius. Are you getting my point? Because this is that circle whose area is minimum. When A, B, these 2 points are the extremities of the diameter of this circle, then the area of this circle will be minimum. That implies its radius will be minimum. Correct? So what will be the length of its radius? That is, it is nothing but AB by 2 because AB is the length of the diameter. So what is AB? This is the length of AB divided by 2. That gives us so it is basically 1 over 2 root 2. Am I correct? So this is the minimum radius of all the circles that are passing through the point of intersection A and B. Right? So let me just reveal the answers. Yes. Is it clear to everyone? Absolutely. Okay. Let me take the next problem. What is this question? Two circles pass through the points 1, 0 and 2, -1. The y-axis is a common tangent. Find the radii of the circles. That's it. Is this question clear to all of you? There are two circles which are passing through these two given points, and they have said that the y-axis is the common tangent. You have to find out the radii of the circles. Again, in this case, I am going to use family of circles, right? Any circle which is passing, the family of all the circles which are passing through these two given points is given by what? We have already learned this. When any circle, the family of all circles passing through two given points. So what you have to find out? You have to find out what I told you, how to find out the family. Remember it? I have to find out an equation of a circle and the line passing through these two given points. And I will find out the family of circles simply by finding out all the circles which are passing through the point of intersection of this circle and the line where they are intersecting. Am I correct? So what is the circle? What is the equation of the circle where you have taken AB as the extremities of the diameter? What will be that equation of the circle? It will be clear? So it's coming to x square minus 3x plus 2 plus y square plus y. So this is my circle. This is the circle, right? In which AB is the extremities of the diameter. Okay, now what is the equation of the line passing through AB? I will use the determinant form. So let me just expand this determinant to get the equation of the line AB. So we are having actually x plus y equals to 1. That's it. So now the family of lines, family of circles which are passing through the point of intersection of this circle and this line is given by let me write it in a general form. Is it clear? Now, as this circle is touching the y-axis, so what we will say? We will say that f square minus c, this will be equals to 0. What is f over here? Your f is, right? F is basically the coefficient of y. 2 times f into y. Can you remember the standard, the general equation? What was the general equation? This was the general equation, right? So if I compare with this general equation, we are getting 2f is lambda plus 1. From there, we will say that f is nothing but lambda plus 1 by 2. This whole square minus c, and c is here, 2 minus lambda, which is equals to 0. So if I just open the brackets, what we are going to have? So from here we are getting lambda is 1 and lambda is minus 7. Is it clear? So if lambda is 1, then the equation of that circle will be, from this equation, we will get, when lambda is 1, I am putting lambda as 1 in this equation. So we are having right, whose center is at and radius is 1 unit, right? And if I put lambda as minus 7 in this equation, we are getting so its center will be at and radius will be so it's coming to 5 units. Am I correct? So the required radii of the circles are 1 unit and 5 units. Is it clear? So this is how we solve problems on family of lines. Because we will see that in maximum problem, I have almost every problem, I should say, I have used family of circles to find out its equation. Because I want you people to be comfortable with the family of circles procedure. Right? That is the reason why I have done every sum, almost every sum, by using family of circles. So I hope you have all learned this family of circles and how to apply those things in the problem. That also we are very clear through the problems that we have discussed so far. Right? So now let us move for the next conception. So now before going for the next conception, let me just give you an idea of actually what we are trying to do in the next part of the lecture. Suppose we have been given 3 lines, L1 equals to 0, L2 equals to 0 and L3 equals to 0. Okay? Now we are having 3 lines and we are forming a triangle by using these 3 lines. Let us say the triangle be this one. Is it clear? This is the triangle. Now I want to find out the equation of its circumcircle. I want to find out the equation of this circumcircle. Clear? So how to do this sum? Tell me the basic method. This is, let us say, my L1, this is L2 and this is, say, L3. These are the 3 lines. Now how to find out the equation of this circumcircle? The basic conception is that let me just solve L1 equals to 0 and L2 equals to 0 to get the coordinate of one vertex A, right? If I solve L1 equals to 0 and L2 equals to 0, we are going to have the vertex A. If I solve L2 equals to 0, L3 equals to 0, then we are going to get the vertex C. And now if I solve L1 equals to 0 and L3 equals to 0, we are going to get the vertex B. Why I found these 3 vertices of the triangle ABC? Because to find out the circumcircle, the equation of circumcircle, I need to find out equation of perpendicular bisectors of two sides. Of any of these two sides, I want to find out the perpendicular bisector. Let us say I have chosen this perpendicular bisector of the side AB, and the perpendicular bisector of AC is this. Now, if I solve, now we can find out its equation, right? We can find out the equation of the perpendicular bisector, because now we know the slope of line AB. We know what is this point, because this point is the midpoint of A and B. So we know the equation of the perpendicular bisector. Similarly, we know the perpendicular equation of perpendicular bisector of this side AC. Now, if I solve these two equations, we are going to get this point, which is nothing but your circumcenter, which is nothing but your, let me give a name of this. Let us say this is P. So P is what? P is our circumcenter. Correct? Now, you know the circumcenter. From the circumcenter, you can find out the distance between any one of its vertices. Whether A or B or C doesn't matter, because you are going to get the same value. So simply find out what is the distance between the circumcenter and the vertices of the triangle. And that will become the circumradius of the circle. Yes or no? So now you know the center of the circumcircle as well as you know its radius. So simply by using center radius form, you can find out the equation of the circle. Am I correct or not? This is the basic method we all used to follow. But tell me honestly, is this method is very short to do? No. You have to do a lot of work here. So let me just give you a new conception by virtue of which you can find out the equation of the circle, but I'm sure it will reduce your steps in a large extent. So what is that method? Listen it very carefully. I'm saying that the equation of the circumcircle will be L1 L2 plus lambda times L2 L3 plus mu times L3 L1 equals to 0. I say that the equation of the circumcircle will be L1 L2 plus lambda L2 L3 mu L3 L1 equals to 0, where lambda and mu are the two parameters. Right? Now I say that this is the equation of the circumcircle. So naturally two questions comes. How you people will believe me that yes sir, this is the equation of the circumcircle? How? Yes, at this point I will say two things. Number one, first of all, if I can prove that this equation is the equation of a circle. First of all, we must know that it's a circle. Otherwise, how this represents a circumcircle? So first, I will prove that it is a circle. Okay? And next, what I will prove, first point, I have proved that it's a circle. It doesn't mean that it will be the circumcircle of the triangle ABC. But yes, you will say that yes sir, it is the circumcircle of the triangle ABC if this circle is passing through 3 points ABC, which are the vertices of the triangle. Now, if I can prove this too, then you will be satisfied in admitting that yes sir, this is the equation of the circumcircle, right? Okay, now let us see this equation. First, I'm trying to prove that it's a circle. So whenever you are writing L1, L2, L2, L3, L3, L1, these are the equation of the given straight lines. I mean the sides of the triangle. So definitely you are getting a general second degree equation. A general second degree equation. Am I correct or not? You are basically getting a general second degree equation the moment I put L1, L2 and L3 in this equation. Yes? Now it will represent a circle. A general second degree equation represents a circle when coefficient of x square will be equals to coefficient of y square. Am I correct? This is first condition. And the second condition is coefficient of xy will be equals to 0 because there should not be any term containing xy. So if these two conditions are fulfilled, then we will say that this general second degree equation represents a circle. Now, since there are two parameters lambda and mu, when you are equating the coefficient of x square equals to the coefficient of y square, you are getting a relation between lambda and mu. Tell me yes or no? That is the reason why I have introduced two parameters. Because arbitrarily we cannot say if I don't introduce lambda and mu, you cannot say, sir, that second degree equation will represent a circle. No. But according to our choice, if I choose lambda and mu, this general second degree equation can be transformed into the equation of a circle. That's the reason why I have introduced two parameters. Is it clear? So now I got one equation involving lambda and mu. Now when you put that the coefficient of xy equals to 0, then again you are getting another equation involving lambda and mu. Yes or no? Now I will simply solve this simultaneous equation to get the value of lambda and mu. And for this particular lambda and mu, this equation is going to represent a circle. That's for sure. So the first part is over. The first part is over that this equation represents a circle. Now the big question. It represents a circle. It doesn't mean that it is a circumcenter. I'm sorry, the circumcircle. Okay. So to prove that it's a circumcircle, I have to show that this circle is satisfied, or I will say that this circle is passing through three given points A, B and C. Now, what is the coordinate of A? How you got the coordinate of A? By solving L1 equals to 0 and L2 equals to 0. That is, if I put the coordinate of A in this equation, you are going to get the value of those equation equals to 0. Naturally, it will satisfy those two equations because A you actually got by solving these two equations, right? So naturally, if I put that coordinate in that line, it is going to satisfy. Okay, now how I will prove that this equation of the circle is passing through A? So what I will do, I will simply put the coordinate of A in this equation. The moment I put the value of A, that is the coordinate of A in this equation, you are going to have L1 equals to 0 and L2 equals to 0. So that implies this first part will become 0. This second part will become 0. At the same time, this part will also become 0. It means what? It means your left hand side and right hand side are both equals to 0. It means that point A satisfies this equation of the circle. It means that your circle is definitely passing through the point A. Am I correct or not? Similarly, how I will prove that point B is also satisfying this circle, that is the circle is passing through this point? Simply I will put the coordinate of B in this equation. Now right after putting coordinate of B in this equation, your L1 becomes 0, L3 becomes 0. So in this case your, as L1 is 0, so this part will become 0. L3 is 0 means this part becomes 0. And as L1 is 0, again this part becomes 0. So again we are getting 0 equals to 0. It means what? That point B is satisfying this equation of the circle. Hence, it proves that the circle is definitely passing through the point B. Am I correct or not? At the same time, you can prove in the similar way that point C is also satisfying this equation. Why? Because point C, actually you got C by solving L2 equals to 0 and L3 equals to 0. So now if I put the point C in this equation of the circle, you see this part will become 0. Why? Because L2 is 0. This part will become 0. Why? Because L2 is 0 again. And this part will again become 0. Why? Because L3 is 0. So again you are getting 0 equals to 0. It means what? That this circle is definitely passing through the point C. Am I correct or not? So simply by calculating lambda and mu, we will directly say that this equation is nothing but the equation of that circumcircle. Am I correct or not? Have you understood the logic? That's the logic. So I have proved two things, that whatever equation that I have formed is basically the equation of a circle. That was the first thing that we have proved. At the same time, we have proved that this circle is passing through the three vertices ABC, which implies that this circle is nothing but the circumcircle of the triangle ABC. That's it. So that much you have to remember. And I am sure, at the same time, you people will be sure that it is going to reduce a lot of work which you have compared to the work that you have done in the first case. Right? Okay. So let me just give you another example. Let us say that there is a quadrilateral, and this circle is circumscribing it. Suppose this is my quadrilateral, any quadrilateral. Let us say this is the quadrilateral, right? Now, this quadrilateral is basically, let us say, A, B, C, D. And the equation of these four sides are given to us. Let us say this is L1 is 0, this is L2 is 0, this is L3 is 0, and this is, say, L4 is 0. Now, I have to find out the equation of this circumcircle. Tell me the basic method how you will solve it. How to find out the equation of the circumcircle in basic method. All I will do is, I will simply solve L1 equals to 0, L4 equals to 0 to get the point A. Then I will solve L1 is 0, L2 is 0 to get the point B. And then I will solve L2 equals to 0 and L3 equals to 0 to get the point C, right? The moment I have 3 points on the circumference of the circle, so we can easily find out the equation of the circle. There is no harm, because we will assume let the equation of the circle be the general form like this. As it is passing to the point A, hence it is going to satisfy this, means you are going to have a relation between GF and C. Similarly, from the second one, if you put B, again you are going to have another relation in GF and C, and put C equals to, the coordinate of C in this given equation to get another equation involving GF and C. Now, if I solve these three simultaneously, you are going to have G, F and C. The moment you have these three unknowns, you know the equation of the circle circumscribing this quadrilateral. Right? This is the basic method of doing the sum. But again, if we try to do it by the method just now we have learned, let us say equation of the circumcircle is let us say it is equals to L1 L3 plus lambda times L2 L4. This is equals to 0. And I'm saying that the equation of the circumcircle will be this. Now again, we have to prove two things. First of all, that it represents a circle. And number two, we have to see whether these points A, B, C, and D are satisfied in this equation or not. That is, whether the circle is passing through the vertices of the quadrilateral ABCD. The moment we prove that, it implies that this circle is nothing but the circumcircle of this quadrilateral, right? So first thing first, let us first prove whether this is a circle or not. Again, this is nothing but a general second degree equation. It is a general second degree equation. Now we know that this general second degree equation will represent a circle when coefficient of x square and coefficient of y square, coefficient of x square and coefficient of y square, okay, this is the coefficient, okay, they must be equal. At the same time, there should not be any term containing xy, means the coefficient of xy, this will be equals to 0. So simply by doing this, we are definitely going to get the value of lambda. Am I correct? We are going to get the value of lambda. Here, there is only one variable. So only one thing will do. The second equation, from the first equation, you are going to have a relation between lambda and some constant. From the second equation, you are also having some relation between lambda and constant. So what I will do, I will solve lambda from one equation and I will put it in the second equation to verify whether it is satisfying or not. If it does not satisfy, then we cannot draw that circle. But if it satisfies the second equation, then we are sure that this circle is representing a circle from this second degree equation. We will be confirming that, right? So from there, we are going to get the value of this lambda. We got the value of lambda. Now the second question comes, said, does it passes through A, B, C, and D? Does it passes through the point A, B, C, D? Let us check. Let me check. You know how you got the coordinate of A? By solving L1 equals to 0 and L4 equals to 0. So if I put the coordinate A in this equation, we are definitely have L1 equals to 0 and L4 equals to 0. So from there, please observe carefully. Let me change the color of the pen. If I put L1 is 0, because the moment you are putting the coordinate A, L1 will become 0. So that makes this thing equals to 0. And it will make this thing equals to 0. Why? Because L4 is 0. So 0 equals to 0 implies that the point A is satisfied. That is, this circle is passing through the point A. Similarly, if I put the coordinate of B, it is going to make L1 0 and L2 0. So again, this part will become 0, this part will become 0. So definitely the circle is passing through point B. Similarly, you can check the point C as well as point D. How we got point D? Simply by solving L4 equals to 0 and L3 equals to 0. We will get point D. So your point C as well as point D is satisfied in this equation. I mean, this circle satisfies A, B, C as well as D. It means what? That this circle is passing through all the vertices of the quadrilateral ABCD. So that represents the circumcircle of this quadrilateral. Am I correct? Is this conception clear to all of us? This exactly the same thing I have summarized here. Okay, so if L1 equals to 0, L2 equals to 0, and L3 equals to 0, this represents three sides of a triangle, then the equation of the circumcircle is this. And use the property of general circle of second degree, general equation. That I will use to find the value of lambda and mu. So the moment you get the value of lambda and mu, you got the equation of that circumcircle circumscribing the given triangle formed by the three lines L1 equals to 0, L2 equals to 0 and L3 equals to 0. Is it clear? Similarly, the equation of the circle circumscribed a quadrilateral whose sides are this 4 taken in order is given by L1, L3 plus lambda L2, L4 equals to 0. And then again apply the general second degree equation condition for representing this thing as a circle. So from there you are going to have the value of lambda. The moment I get the value of lambda, I know the equation of that circumcircle. Is it clear to all of you? Is this conception clear to all of you? This is actually a tool. We will try to use this method whenever this kind of questions are involved. Because whenever this kind of questions are involved, if you apply this method, definitely you are going to solve the sum at much easier way, number one, as well as it is going to save your time, which is, the most valuable thing in the examination, right? So let me take one example based on this. So in this question, they have said, find the equation of the circumcircle of the triangle formed by these three lines. So here we will use the conception that we have learned right now. Let the equation of the circumcircle be, what was the form? L1, L2. L1, L2. This is my L1, let us say. L1 is x plus 2y minus 3. L2 is 3x plus y plus 1. And L3 is 4x plus 5y plus 2. So L1, L2 plus lambda times L2, L3 plus mu times L3, L1 right, which is equals to 0. So this will be the equation of the circumcircle circumscribing the triangle formed by these three given lines. So here our main task is to find out only the value of lambda and mu. That's it. The moment you get the value of lambda and mu, the equation this will represent that required circle which is circumscribing this triangle. Right? So how to find out that? I told you this is a general second degree equation. So it will represent a circle only when the coefficient of x square and coefficient of y square, they are equal. So what is coefficient of x square here? Don't multiply the whole thing. Don't multiply the whole thing until and unless it is required. In this case, to find out the coefficient of x square, no need to multiply the whole thing. Simply find out mentally what will be the coefficient of x square. From here we are getting the coefficient of x square as 3. From here we are getting 12 lambda, and from here we are getting 4 mu. That's it. Nothing else. Then find out what is coefficient of y square. Again, multiply this. From this one, I am getting 2y square. So it is 2. Coefficient is 2. From the second one, we are getting 5 lambda. And from the third one, we are getting 10 mu. Am I correct? Now, the coefficient of x square and coefficient of y square, they are same. So let me just simplify a little bit. 7 lambda minus 6 mu equals to minus 1. Is it clear or not? Is this clear or not? So this is the first equation that we got. Now to find out the second equation, I have to find out what is the coefficient of xy. Right? What is the coefficient of xy? Again, in this case, don't multiply the whole thing. Simply find out mentally what should be the coefficient of xy. From this first two, we are getting the coefficient of xy is when this x is multiplied with this y, and when this 3 is multiplied with this, we are getting the coefficient of xy. Here in this case, it will be 1 plus 6, right? From the second one, what will be the coefficient of xy? When 3x is multiplied with 5y, that is 15 lambda. When 4x is multiplied with y, that is 4 lambda. Am I correct? This is the coefficient of xy. And from the third one we are getting 8 mu plus 5 mu. Right? And this is the coefficient of xy when we expand this whole expression. So this has to be equals to 0. So from here we are getting the second equation we got. Am I correct? So this is the first equation and this is the second equation. Now what is our task? Is to simply find out the value of lambda and mu from equation 1 and equation 2 solving simultaneously. So what I will do, I will simply multiply first equation with 13 and the second equation with 6. So what we are getting? 91 lambda minus 78 mu equals to minus 13, correct? And from the second one we are getting, when we multiply with 6, we are getting 114 lambda plus 78 mu equals to minus 42. Okay, so let me just add this to what we are getting. Correct? So lambda gives us, that's it. So simplify this little bit, minus 11 divided by 41, correct? So the value of lambda is minus 11 over 41. Now put the value of lambda in the first equation to get the value of mu. 6 mu is 7 lambda plus 1. So 7 times lambda, that gives us minus 77 over 41 plus 1 gives us minus 77 plus 41 over 41. So that gives us minus 36 divided by 41. Clear? Therefore, your mu is minus 6 over 41, right? So we got the value of mu, we got the value of lambda. Now we will simply replace this value of lambda and mu in this equation, and then we will multiply and simplify it to get the equation of the circumcircle. Is it clear? Is the modus operandi of doing this sum is clear to all of us? Absolutely. Okay. So now let us jump into our next conception, which is how to find out the angle between two circles. It's not only the angle between two circles, to find out the angle between any two curves. Remember this. This we are going to cover in application of derivative in class 12. So to find out the angle between any two curves, it is basically the angle between the tangents at their common point of intersection. What I have said, angle between, I am considering here circles because we are considering circles, but it is true for all the curves. So angle between, I'm writing it in general way so that you can understand. In general case, you will simply plug into the circle, you are going to have the same thing. So angle between any two curves is the angle between their tangents at their common point of intersection. Am I correct? So how to find out the angle between two circles? Let me just say, let me just draw two circles first. So this is my first circle and let us say this is my second circle. Okay, let me just draw it a little bigger. Now, the thing is that to find out the angle between these two circles is same as if you draw, this is the point of intersection, right? This is the common point of intersection. So what I will do, I will simply draw tangents to these 2 points. For the first circle, this is the tangent, and for the second circle, let us say this is the tangent. Okay, is it clear? Now, the angle between these two curves is same as the angle between their tangents at this common point of intersection. Now, I am telling you, as these two circles are symmetric. These circles are symmetric. So, the angle here, the angle between these two tangents, somebody can say, sir, I can find out the angle here also. But yes, in case of circles, since the circles are symmetric, this angle and this angle, they will be same. If this angle is your alpha, then this angle is also your alpha. Are you getting my point? Or if you write this angle is theta, then this angle is also theta. Okay, so I'm not considering the second part, I'm only considering the first one because they will be same. So no point of finding out the angle between the circles at this point as well as at this point. Okay, if you find out the angle between the circles at one point, it is same as finding out the angle between the circles at the second point because they are same. So let me just erase this portion. Okay, so I have to find out the angle between these tangents, which is actually the angle between the two circles, right? So what I'm trying to do here, I am simply joining the centers with the point of contact. Okay, where the two tangents are drawn. Let us say these are my two tangents. Okay, I'm sorry, these are the line joined from the center to the point of contact. And the point of contact is common for both the circles. So we can say that this is my center C1, this is my center C2. So we can say that these two lines will definitely pass through the center of the respective circles. Why? Because they are perpendicular to the tangents. These are the normals. So this angle is 90 degree. Again, this angle is also 90 degree. Let us say this angle is alpha. The angle between the two radii is say alpha. But this angle, the angle between the tangents is still remains same, which is same as this angle because they are vertically opposite angles. So this angle will also be equals to theta. Am I correct? Now one thing I can easily see from here, that your alpha plus 90 degree plus 90 degree plus theta is this whole point angle, which is nothing but your 360 degree, right? So your theta is coming to 180 minus alpha, right? Let us keep this thing in our hand. Okay, so now what I'm doing, I'm simply joining these two centers. Right? The angle between these two radii is alpha. And let us say the radius of the first circle be R1 and the radius of the second circle be R2. Now please observe, let us say this point of contact be A. I have no place to write. Let me write it here. Let me write it here. So this point is A. So in the triangle, look at carefully, in the triangle A, C1, C2. In the triangle A, C1, C2, we can say that cos of alpha is basically R1 square plus R2 square minus C1, C2 square divided by 2 times R1, R2. This is what is called your cosine rule. This you have to learn in the properties of triangle. In any triangle, we find out the angle in this way. So cos alpha, this is called cosine rule. Cos alpha is r1 square plus r2 square minus c1 c2 square divided by 2 r1 r2. Is it clear? But the angle between the two circles is not alpha. The angle between the two circles is this theta. That is the angle made by the two tangents at their point of intersection, common point of intersection. So in place of alpha, I can replace it from this equation. I can replace this thing as 180 degree minus theta, which is your r1 square plus r2 square minus c1 c2 square divided by 2 r1 r2. Right? Now cos 180 minus theta will give us minus cos theta, which is the same thing. Okay, so we can write our cos theta is nothing but modulus of r1 square plus r2 square minus c1 c2 square. Now c1 c2 square, this distance, let me denote it by d. That is the distance between the two centers of these two given circles. So it will be r1 square plus r2 square minus d square divided by 2 times r1 r2. Is it clear to all? So this is the angle between the two circles, which is nothing but r1 square plus r2 square minus d square divided by 2 r1 r2. Now the question can come, sir, will I have to remember this, the method that you have done to find out this value? I will say, if you can remember, it's okay, but no need to remember it. You simply understand how we are getting the angle between two circles. Again, the angle between two circles is always the angle between their tangents to their point of contact, common point of contact. Okay? And in this case, we are going to have two angles between the circles, because at this point also we can find out the angle. But here, in the case of circles, no need to find out this angle, because this angle and this angle, they will be same, as circles are symmetric to each other. Is it clear? Circles itself, they are symmetric. So that is why no need to find out this angle and this angle, they will be same. So simply find out only one angle. So what is that? Your cos theta is modulus of r1 square plus r2 square minus d square divided by 2 times r1 into r2, where d is the distance between their centers and r1, r2 are the radii of the given circles respectively. Is it clear now? Absolutely. So we have to remember this formula. Okay. So now let us come for the most interesting part of angle between two curves or two circles in this case is what called your orthogonal circles. Now two circles are said to be orthogonal when the angle between them, what we got, our angle is cos theta equals to modulus of r1 square plus r2 square minus d square divided by 2 times r1 r2, right? This is the angle between two circles. Now if this angle theta is 90 degree, so obviously cos 90 degree is 0 and cos 90 degree is 0. So that implies your r1 square plus r2 square minus d square, this gives us 0. So from here we can write that r1 square plus r2 square is basically d square. Very, very important conclusion. What is that? Two circles will intersect each other orthogonally. Orthogonally means the angle between these two circles is 90 degree. If it is so, then r1 square plus r2 square will be always equals to d square, where d is the distance between the center of these two circles. Okay? Let us consider that the equation of the first circle be x square plus y square plus 2g1x plus 2f1y plus c1 is 0, and the equation of the second circle is 2g2x plus 2f2y plus c2 equals to 0. Now suppose these two circles intersect each other orthogonally, then the property is R1 square plus R2 square will be equals to D square. Now what is R1? That is the radius of the first circle. That is root over of G1 square plus F1 square minus C1. And the radius for the second circle is G2 square plus F2 square minus C2. So what will be your R1 square plus R2 square? It is G1 square plus F1 square minus C1 plus G2 square plus F2 square minus C2, which is equals to the distance between their centers. Center for the first circle is minus G1 minus F1, and that of the second circle is minus G2 comma minus F2. So what is the distance between the centers? The distance between the centers will be root over of G1 minus G2 whole square plus F1 minus F2 whole square. Is it clear or not? So D square will give us what? G1 minus G2 whole square plus F1 minus F2 whole square. So now let me open the brackets. G1 square, G2 square minus 2 G1 G2 plus F1 square F2 square minus 2 F1 F2. Am I correct? So G1 square, G1 square, G2 square, G2 square, then again F1 square, F2 square, all goes off. So we are left with 2 G1 G2 plus 2 F1 F2, that gives us only C1 plus C2. So this condition also we have to remember. This condition is for what? This condition is for when the two circles intersect each other orthogonally. So two formulae we have to remember for orthogonality of two circles. One is R1 square plus R2 square is D square, and another one is 2 times G1 G2 plus 2 times F1 F2 equals to C1 plus C2. So these two formula we have to remember by heart. Okay? Okay, let's move for problems based on this orthogonality. In this question, they have said we have to find out the locus of the centers of those circles which cut these two given circles orthogonally. The first circle which is given to us is x square plus y square plus 4x minus 6y plus 9 equals to 0. Here we have to find out what is our G and F. As we all remember that for a general equation of a circle, for any general equation of a circle, the coefficient of x is 2g and the coefficient of y is 2f, right? So in this case also, your 2g1 will be equals to 4. That implies g1 is 2. Similarly, 2 of f1 will be minus 6, which gives us f1 is minus 3. Is it clear? And the constant c1 in this case is 9. This is for the first circle. What about the second circle? The second circle is given. So in this case, your 2g2 will be minus 5. From here we can write g2 is minus 5 over 2, and 2f2 is 4 implies f2 is 2. And your c2, the constant, is minus 2 here. Is it clear? So these are the two basic things I have done for these two given circles. Now you have to find out the locus of the center of that circle which cut these two circles orthogonally. And we know that the condition for orthogonality is that 2 times g1 g2 plus f1 f2 will be equals to c1 plus c2. For any two circles intersect each other orthogonally, the condition is this, right? So now we have to find out the locus of that centers of those circles which cut these two circles c1 c2 orthogonally. So let me say the equation of the circle be this one. Is it clear? Let us say this is that equation. So the center is basically minus g comma minus f. Now I have to find out the locus of the center of those circles. So let me say h comma k be any point on the locus. Any point on the locus. So what you will say? You will say, sir, h is minus g implies g is minus h, and k is minus f implies f is minus k. So I have to find out a relation between h and k, means I have to find out a relation between g and f with the constants, and that will be the equation of the locus. Am I correct? Okay, so for this one, so let me denote this circle by C3. Now C3 and C1, they will intersect each other orthogonally when I am applying this condition, when 2 times g into 2 minus f into 3, that will be equal to C1 plus C2, which is nothing but C plus 9. Have you got it? Have you understood? As C1 and C3 are intersecting orthogonally, so 2 times G1, G2 plus F1, F2 equals to C1 plus C2. That exactly I have used here. So we are getting basically 4G minus 6F equals to C plus 9. And this is our equation 1. Right? Again, I am applying the same formula for C2 and C3. Why? Because they are also intersecting each other orthogonally. So in that case, what you will write? You will write 2 times g into minus 5 over 2 plus 2 times f equals to c minus 2. So if we multiply, we are going to have minus 5g plus 4f equals to c minus 2. And this is our second equation. So to find out the equation of the locus, I have to find out a relationship between g and f, which eventually gives us the relation between h and k. So if I subtract equation 2 from equation 1, we are going to have 9g minus 10f equals to 11. Is it clear? Therefore, if I replace g by minus h, we are going to have minus 9h plus 10k equals to 11. So that gives us 9h minus 10k plus 11 equals to 0. Therefore, the required equation of the locus, is 9x minus 10y plus 11 equals to 0. Is it clear to all? So what I have done in this question is simply I have applied the property that when two circles intersect each other orthogonally, then the formula is 2 times g1 g2 plus f1 f2 will be equals to c1 plus c2. And in this question, you should be careful about one thing of finding out g1 and f1. Because as we know that our center is always minus g1 minus f1, so students get confused what should be the value of g1 and f1. So in that case, there should not be any confusion, because whatever coefficient of x is there is basically your 2g. And whatever coefficient of y is there along with the sign is your 2f. So from there you have to find out the actual value of g1 and f1. Is it clear? And then simply apply this formula when the two circles intersect each other orthogonally to find out the locus of the center of those circles in this problem. Is it clear? So that way we have done this sum. Okay, let us move for a next problem. See this question. They have said two circles having radii. Let me draw these two circles first. Two circles are having radii R1 and R2. They intersect each other orthogonally. Right? Find the length of the common chord. Okay. So I have to find out the length of this common chord. This is the common chord. So I have to find out this length. So let me do one thing. These are my two centers of the first circle and the second circle. This is C1, this is C2. Let me just join the center with this point of intersection. Okay, and let me join these two centers. Okay, so now we have to find out the length of the common chord AB. Okay, so how to do it? Now, one thing we know that whenever we are joining these two centers, it is going to bisect this common chord. It is going to bisect the common chord. That's for sure. That we know. Because we have already done it by taking the, by proving the two triangles similar and all these things we have already done in the previous lectures. So I'm not going for that. So one thing for sure that this length and this length, they are same. Now, since these two circles intersect each other orthogonally, that means this angle is 90 degree, correct? So now tell me one thing. This is the radius R1 and this is the radius R2. I have to find out the length of AB. Let me say this point where it is intersecting the line joining the two centers be P. Now, what is the area? What is the area of the triangle AC1C2? As angle C1AC2 is 90 degree. Therefore, we will say that area of triangle AC1C2 is half into base into height. Okay. This is one way of finding out the area of. Now, can we assume in this way that the area of the triangle AC1C2 is same as half into base, that is C1C2 into AP. Am I correct? What is C1C2? That is the distance between these two centers. If we consider the triangle AC1C2, we can easily see from the Pythagoras theorem that R1 square plus R2 square is basically C1C2 square. Therefore, your C1C2 is basically under root R1 square plus R2 square. So now, as these two represents the area of the same triangle, so I can say these two are equal. Am I correct? So now, half of goes off. This is R1, R2 divided by C1, C2 is your AP. So your AP is coming to R1, R2 divided by C1, C2 is basically root over of R1 square plus R2 square. Now AP is basically half of AB. AP is basically half of AB. Just now I told you that P is the midpoint of AB, which is your R1 into R2 divided by root over of R1 square plus R2 square. So from here we are getting that your AB is nothing but 2R1 R2 divided by root over of R1 square plus R2 square. Therefore, the length of the chord AB in this case is this one. Is it clear to all? Is this clear to all? Let me reveal the answer. Yes. Is this clear to all of you? Absolutely. Okay. Now let us come for the next problem, which is this. See this one. Find the equation of the circle through the point of intersection of this circle and this circle. You have to find out the equation of that circle which is passing to the point of intersection of these two circles. So the moment I see this, the first thing that it comes to my mind is I have to apply family of circles. Any circle which is passing to the point of intersection of two circles, we know that its equation is S1 plus lambda times S2 is equals to 0. Therefore, the equation of any circle which is passing through this given two circles, through the point of intersection of this given two circles is given by Yes or no? This is the equation of that circle which is passing through the point of intersection of these given two circles. So let me write it in the general form. We are getting from here we are getting minus 4x plus 6x lambda, and then we are getting minus 6y plus 4y lambda minus 12 lambda equals to 0. So from here we are getting x square plus y square minus 4 minus 6 lambda x minus 6 minus 4 lambda y minus 1 plus lambda equals to 0. Am I correct? Therefore, if I divide by 1 plus lambda, so we are getting, because as we all know that lambda cannot be equals to minus 1. Here your lambda can be any real value except minus 1. So 1 plus lambda will never become equals to 0. So I'm dividing by 1 plus lambda, we are getting 4 minus 6 lambda by 1 plus lambda x minus divided by 1 plus lambda y minus 12 equals to 0. Am I correct? So now if I ask you what is your g in this case, your 2g will be 4 minus 6 lambda by 1 plus lambda, definitely with a minus sign. So from here we are getting your g is coming to 3 lambda minus 2 divided by 1 plus lambda, right? And what about your f? 2f is minus 6 minus 4 lambda by 1 plus lambda gives us what? F equals to 2 lambda minus 3 by 1 plus lambda. Okay? And what about your c here? It's minus 12. Now this circle is cutting this circle orthogonally. It is cutting this circle orthogonally. Now my first thing is that what is your g1 here? 2g1 is basically minus 2. That gives us g1 is minus 1. Please be careful. See how I am considering my g1 and f1, as I have already repeated in the previous sum. So g1 is minus 1 in this case, your f1 in this case is 0, and your c1 in this case is minus 4. Am I correct? Now as they are intersecting each other orthogonally, so I will say 2 times g1 plus f1 equals to c plus c1. That is the condition. So we can write 2 times 3 lambda minus 2 by 1 plus lambda into minus 1. As f1 is 0, so this part becomes 0, which is equals to minus 12 minus 4. So from here we are getting minus 3 lambda minus 2 by 1 plus lambda equals to minus 8. Is it clear? Actually, it is coming minus 16 and then divided by 2 gives us minus 8. Minus minus goes off. So it's 3 lambda minus 2 becomes 8 plus 8 lambda, correct? So we are having 5 lambda equals to minus 10. So that gives us lambda is minus 2. Got it? So we got lambda is minus 2. Then what will be the equation of the circle? What is the equation of the circle? Let me put it here. Let me put it here. Let me put it here to get the equation of that circle. It will be what? X square plus y square. In place of lambda, I am putting minus 2. So we are having 4 plus 12 divided by minus 1. X minus 6 plus 8 divided by minus 1y minus 12 equals to 0. So it is coming like x square plus y square plus 16x plus 14y minus 12 equals to 0. That's it. That's your answer. Is it clear to all? Absolutely. So I have done 2-3 sums on orthogonality. So I hope now you are clear about how to use orthogonality formula in the problem. Is it clear? Let me take some more sums on orthogonality. Let us consider this problem. They have said that there are two circles, lambda 1 and lambda 2. Both of these are passing to the point 0, a and 0, minus a. You see, these three conditions are given to us, 1, 2 and 3. On the basis of these three conditions, we have to prove this one, right? So now, the first condition is that the two circles, lambda 1 and lambda 2, are passing through these 2 points. So let me consider only one circle as, let me just write it, then I'm telling you. Fy plus, let us say C has already been taken. So let me just write this thing as K equals to 0, right? This is the equation of the circle. Now, since there are two circles, you don't need to take equation of two circles. No, because if you observe, you will find that they are actually doing the same thing. They are doing the same thing. So whatever answer we are going to get from one equation will be very much valid for the second equation because they are doing the same thing. Are you getting my point? Okay, so now this circle is passing through the point 0, a and 0, minus a. Hence it must satisfy this equation. Let me just put it. So we are having is it clear or not? Now if you consider two circles, you are going to have the same relation. When you put 0, a in the second equation, you are going to have the same thing. Only thing is that in that case, I will take G1, F1, K1. And for the second circle, I will take G2, F2 and K2. So for the second circle, if you put 0, a, you are going to have a square plus 2 f1a plus k1 equals to 0 for the first circle. And for the second circle, you will get a square plus 2 f2a plus k2 equals to 0. That is, you are getting exactly the same thing. Are you getting my point? It will be an unnecessary work if you take two circles at a time to solve this problem. Okay? When required, I will definitely take two circles. But when this same thing is happening, I mean the symmetric thing is happening, why to take two circles to solve this? I will only take one circle and do it, and I will assume that the same thing is happening for the second circle. Getting my point? Okay, so this is my first equation I got for both the circles. Now, it is also passing through 0, minus a, so let me put it there also. This is 0 minus 2fa plus k equals to 0. So what we are getting? We are getting the second condition, a square minus 2fa plus k equals to 0. So this is our second equation. Is it clear? True for both the circles. Right? So now if I subtract these two equations, what we are getting? We are getting 4 times f a is equals to 0. So that implies what? Your f is coming to 0, because as a is not equals to 0, therefore your f will be equals to 0. That is, see, what is the benefit of taking only one circle? Here we got f equals to 0. Means it is true for both the circles. In both the circles, your f1 will be equals to 0, as well as for the second circle, your f2 will be equals to 0. So I am not taking two circles at a time. I am doing with the general one, and it will be valid for both the circles, right? So your f1 is 0, as well as for the second circle, f2 is 0, right? Okay, so now let me add these two equations, what we are getting. If I add these two equations, we are getting 2a square plus 2k is 0. So from here we are getting basically k is nothing but minus a square. K is nothing but minus a square. It means what? It means for the first circle, your k1 will be minus a square. And for the second circle, your k2 will be equals to minus a square. Got it? Okay, so the first condition we have solved. Now let us come for the second condition which is given to us, that both of them are touching this line mx minus y plus c equals to 0. That is, for both the circles, this line is a tangent. This line is a tangent. Now, what we know? We know that basic property that whenever there is a tangent for a circle, we will drop a perpendicular from the center of the circle to the tangent, and it will be equals to its radius. So now the center of this circle is at minus g minus f. So if I drop a perpendicular from minus g minus f, what will be that perpendicular length? It will be minus gm plus f plus c divided by root over of m square plus 1. Am I correct? And this will be nothing but the radius of this circle. The radius of this circle is g square plus f square minus k. So this will be equals to root over of g square plus f square minus k. That's it. So let me simply square both sides. What you are getting? Gm minus f minus c whole square, which is equals to g square plus f square minus k into m square plus 1. As we have your f equals to 0, so I can put f equals to 0 over here. So we will get gm minus c whole square is basically g square minus k into m square plus 1. Tell me yes or no. So now let me just open this bracket to get g square m square plus c square minus 2cgm, which is coming to g square m square plus g square minus km square minus k. So g square m square goes off. So we are left with g square plus 2cgm minus km square minus k minus c square equals to 0. So let this equation be as it is. Let us not touch this equation right now. Definitely it will be required afterwards. Now we are left with the third condition, what they have said, that these two circles cut each other orthogonally. Now you have to write down two separate equations, because I have to use the formula 2g1 g2 plus f1 f2 equals to c1 plus c2. So naturally now I have to consider the circles individually. Okay, no problem. I will say that the two circles are x square plus y square plus 2g1x plus 2f1y plus k1, and another one is 2g2x 2f2y plus k2 is 0, right? Now as these two circles intersect each other orthogonally, so what I will write? I will simply write 2 times g1 g2 plus f1 f2 will be equals to k1 plus k2. Tell me yes or no. Now as we all got that f equals to 0 for both the circles, therefore this part will become what? This part will become 0. So that implies 2 times g1 g2 will give us k1 plus k2. Are you getting the point? Your f is 0, true for both the circles. That is, f1 is also 0 as well as f2 is equals to 0. Therefore, your condition has been transformed into this form: 2 times g1 g2 equals to k1 plus k2. Now we can easily see that your k1 is minus a square, k2 is minus a square, right? So from here we can write 2 times g1 g2 is minus a square minus a square. That gives us g1 g2 is basically minus a square. Got the point? Because this is nothing but minus 2a square. 2 will go off. So g1 g2 is minus a square. So now to prove this, I have to remove this g1 g2. But how I will remove g1 and g2? Now please refer to this equation. This is basically a quadratic equation in G. So definitely we are going to have two values of G. One will be G1 and another one will be G2. Now what will be the product of two roots? G1 and G2. What will be the product of two roots? It will be minus km square plus k plus c square. See how quadratic equation is coming into the picture. Yes or no? The product of two roots is coming to minus km square plus k plus c square. So what I will do, in place of this G1, G2, I will simply write minus km square plus k plus c square equals to minus a square. Am I correct? So what you are getting basically, let me write it here. Let me write it here. Let me write it here. So you are getting basically k m square plus k plus c square is coming to a square. Right? Now what is your k? K is basically your minus a square, right? K is basically minus a square. So let me replace this. We are getting minus a square m square minus a square plus c square is a square. So from here we are getting, if we take everything in the right hand side keeping c square in the left hand side, we are getting 2a square plus a square m square. Am I correct? Now let me take a square common. So we are having c square equals to a square into m square plus 2. Hence proved. Is it clear? Is this conception clear? This sum is a very, very good sum, you know, from that point. So if you have not understood the thing, because I have everywhere I have used the basic property. If you have not understood this problem, what I will suggest you after my class, you come to this portion, rewind the video and see. You will definitely understand, because right now you have done the orthogonality of two circles. Okay, so maybe there will be a little bit problem, but there will be no problem if you revisit this side and if you revisit this video and play this part of the question. I am 100% sure you people will be absolutely clear. Okay, so let's move for the next problem. So this question, it is almost the same question as the previous one, same ice cream with a different topping. Here they have said that there are two circles lambda 1 and lambda 2 such that they both passes through A comma B in the first quadrant. They both touch the coordinate axis. Now simply by observing these two, I can say let the center of the required circle be at R comma R. As it is touching both the coordinate axis, so the center will be at R comma R and the radius here is R for both the circles. Again I am telling you, because they are doing the same thing. Thus the equation of the circle will give us x minus r whole square y minus r whole square equals to r square. So now if I open this, we are going to have this goes off. So we are left with x square plus y square minus 2rx minus 2ry plus r square is 0. Am I correct? Therefore, in this case, what is our g? Our g is minus of 2r. That is 2g is minus of 2r implies g is basically minus r. Similarly, 2f is minus 2r implies f is minus r again. Is it clear? And your c is nothing but r square. Now what they have said? Now they have said in the third case that these two circles cut orthogonally. These two circles cut orthogonally. Now one thing I missed, that is they are passing through the point A comma B. Hence it must satisfy this equation. Therefore we can write a square plus b square minus 2ra minus 2rb plus r square comes to 0. Is it clear? So let it be like in this form. Definitely it will be required in the last condition. So I will use it there. So now these two circles cut each other orthogonally. So what I will write? The two circles will be x square plus y square minus 2r1x minus 2r1y plus r1 square equals to 0, and the second one will be 2r2x 2r2y plus r2 square equals to 0. Right? As they cut each other orthogonally, so what you will write? You will write 2 times f1 f2 plus g1 g2 equals to c1 plus c2. In this case, our f1 is minus r1, f2 is minus r2. Similarly, g1 is minus r1, g2 is minus r2. So if I put those conditions in this given equation, what we are going to have? 2 times r1 r2 plus r1 r2, which is equals to c1 plus c2, that is r1 square plus r2 square. Is it clear? So that gives us 4 times r1 r2 equals to r1 square plus r2 square. So if I break this one, it can be written as r1 plus r2 whole square minus 2 r1 r2. So that implies r1 plus r2 whole square is basically 6 r1 r2. Am I correct? Now let us come to this equation again. I can write this equation as a quadratic equation in R. Look it carefully. It is r square minus 2 times a plus b into r plus a square plus b square, which is equals to 0. This is a quadratic equation in R. So we are having two roots, r1 and r2. From here we can write r1 plus r2 is basically minus a plus b 2 times a plus b, that is your sum of two roots, and the product of two roots will be a square plus b square. So now simply replace those values in this equation. We are getting 4a plus b whole square equals to 6 times a square plus b square. So let me open it. 4a square plus 4b square plus 8ab gives us 6a square plus 6b square. So from here we are getting 2a square plus b square equals to 8ab. So from here, let me write it here. So from here we can write a square plus b square is basically 4ab, and if I divide by ab we are getting equals to 4. So from here we are having a square by ab plus b square by ab equals to 4, implies a by b plus b by a is 4, hence proved. Have you understood this? Have you understood this? Same thing, same problem. I've used the same property. Okay? So definitely you have understood. If not, as I mentioned just now, that you will rewind this video after my class and see this problem again. If you face any sort of problem, even in that case, if you are not able to understand, please write in the comment box. I will definitely get back to you to your problem. Okay, let's move for the next problem. This sum came in JEE Advanced 2014. What they have said? They have said that a circle S passes through the point 0, 1. A circle S passes through the point 0, 1 and is orthogonal to the circles this as well as this. So the two circles are given. Let me write the first circle as x minus 1 whole square plus y square is 16. So let me just break it. x square minus 2x plus 1 plus y square minus 16 is 0. So from here we are getting x square plus y square minus 2x minus 15 equals to 0. So here your G1, 2G1 is minus 2 implies G1 is minus 1. And we can easily see that your F1 here is 0. So F1 will be 0 in this case. And your C1 here is minus 15. This is for circle 1. And the circle 2 is what? Circle 2 is x square plus y square minus 1 is 0. So easily we can see that your G2 in this case is 0, F2 is 0, and C2, that is the constant term in the expression of the circle, is minus 1 here, right? Now, these two circles are orthogonal to the circle S, which passes through the point 0, 1. Is it clear? So let me write the equation of that circle be x square plus y square plus 2gx plus 2fy plus c equals to 0. Okay? The general equation of a circle I have taken. Now, as it is passing to the point 0, 1, hence it must satisfy this equation. Therefore, we are getting 0 plus 1, 0 plus 2f plus c equals to 0. So, from here we are getting 2f plus c equals to minus 1. Let it be there. Okay? As this circle is orthogonal to C1, let me denote this circle by C3. So, as C1 and C3 are orthogonal, so what I will write? I will simply write 2 times G1 plus F1 equals to C1 plus C. So what we are getting from here? 2 times G1 is minus 1, so it gives us minus G. F1 is 0, so this becomes 0, which is equals to C1 is minus 15 and C we don't know. So we are basically getting an equation something like this: minus 2G is minus 15 plus C. Is it clear? So this is one equation that we got. Now to find out G and C, we need another equation. And that equation will be formed as they have given C2 and C3. Again, they are orthogonal. So what we will write? We will write 2 times G2 plus F2 equals to C2 plus C. So from here we are getting, as G2 and F2 both are 0, so this is 0. And C2 is minus 1 and C is, in this case, I don't know. So C is C. So we have C is coming to 1. Your C is coming to 1. Now if C is 1, what is your G? Let me just give a number to this equation. So if you want to find out G, I will put the value of C in equation 2. So putting C equals to 1 in 2, we get what we get? Minus 2G is basically minus 15 plus 1, that gives us minus 14. That implies G is nothing but 7. Am I correct? G is nothing but 7. Now to get the value of F, putting C equals to 1 in equation 1, we get 2 times F plus 1 is minus 1. So from here we are having F as minus 1. Am I correct or not? So you got F, you got G. Therefore, the equation of the given circle is x square plus y square plus 14x minus 2y plus 1 equals to 0. Therefore, its center is at minus 7 comma 1 and its radius will be root over 7 square plus 1 minus 1. So that gives us 7. Is it clear? Therefore, the center is at minus 7 comma 1 and radius is 7. Hence, option B and C both are correct. Is it clear or not? Is this conception clear or not? Yes, B and C are the correct answers. Okay? I hope you have understood this problem. Okay? So let's end our class here. See you very soon with my next video on circle. Till then, stay tuned to us. Don't forget to subscribe, like, and share this video. Thank you so much.